Hi everybody. In this section we're going to study one specific type of discrete probability distribution, and it's called the binomial probability distribution. We're going to start by defining what a binomial probability experiment is. A probability experiment is said to be a binomial probability experiment if it has all four of the following characteristics. There are a fixed, specific number of trials. And by the way, we'll see in some examples coming up what exactly all these things mean. 2, the outcome of each trial is independent of the other trials. Independent just means that the outcome of one trial doesn't affect the outcome of another trial. 3, for each trial, there are two mutually exclusive outcomes. That can be 0 and 1, it could be blue and red, it could be sick or healthy. To be generic, these are typically called success and failure. And those are kind of weird names because the one that's called success doesn't mean that the outcome is good and the one that's called failure is bad. It's just that the one that's called success is the one we're going to count. Oh, and mutually exclusive means that if one outcome happens, the other can't happen. For example, like dead or alive, those are mutually exclusive. If you're dead, you can't be alive. If you're alive, you can't be dead. But sick and alive are not mutually exclusive because you could be both sick and alive. Last, the probability of success and failure is the same for each trial. Now, there's some notation that's standardly used in this situation. We're going to use a lowercase n to represent the number of trials. The lowercase p is going to represent the probability of success in any one trial. We're still going to be using an uppercase P for the probability of an event happening, and this right here is an illustration of why I was kind of insisting on using an uppercase P for that, because now we're using a lowercase p for a different aspect of probability. X will be the random variable representing the number of successes in n trials. Remember I said that the ones that we're calling successes, that just means those are the ones we're counting. And x is the random variable that counts them. So notice that the value of x has to be between 0 and n. You can't have less than 0. The fewest number of successes you could have is none at all, 0. And the most you could have in n trials is n. Okay, let's see some examples of probability experiments that are and aren't binomial so that we can get a better feel for what all this stuff means. Here's our first example. A coin is tossed 100 times and the number of tails is recorded. Is this a binomial probability experiment? Why or why not? So let's go through the 4 things that a probability experiment has to fulfill in order to be considered binomial. First, we have to have a fixed specific number of trials. Now, in this experiment of tossing a coin 100 times, each toss is a trial. And we're told there's going to be 100 trials. So that's a specific number that's not going to change. The number of trials we're going to call n. So the number of trials is n equals 100. That's fixed. In other words, unchanging, and it's been specified. What else does this need to satisfy to be binomial? Okay, the outcome of each trial is independent of the other trials. So the thing we're asking ourselves here is, say I flip the coin, does whatever I get on that flip, does it affect future flips? So if I get a tails, is that going to affect what I get on future flips? And no, it's not. The flips, in other words, the trials, are independent. Next, each trial needs to have two mutually exclusive outcomes. No more than two, no less than two. Well, in a trial of flipping the coin, yeah, there's two outcomes, heads or tails. And the fourth one, the probability of success and failure needs to be the same in each trial. By the way, since we're counting tails in this experiment, that means that tails would be the one where we are referring to as success. So back to the fourth condition, that the probability needs to be the same in each trial. Yes, we have that fulfilled. The probability, that's we're calling lowercase p, is 50% in every trial. It does not change. So, since our probability experiment satisfies all four of the conditions, we can say that this is a binomial experiment. In the next video, we'll go through some more examples.